Hi everyone, welcome back to my video. I'm going through PSLE 2020, question number 36. So Ravi rolled a metal ball from point X at low speed past a strong magnet on the table. So we got a metal ball, okay, you roll past here on this possible path. So then you can see that the path that it took, it follow the direction of it being pushed in this case. Explain why the metal ball moved past the magnet in a straight line. So why did it move in a straight line? Why did it not go here, or even not go here? Okay, so this question is really asking you why it proceeds here, not the other path. Okay, so I will show you an experiment regarding this. Okay, so in front of me I have a very strong magnet. To prove it, I will have an iron clip. Okay, this iron clip. You can see that it is pretty strong, right? So you can kind of attract it, and I can even pull it. Okay, so let me just remove this part. So in the first part of the question, we have a ball, okay, that is rolling past. Okay, so the question is something that looks like this. Okay, so the ball actually went straight past. Okay, straight past the magnet. So it shows that it was neither attracted nor repelled to the magnet. Okay, there's no interaction. This must show you that the ball itself is a non-magnetic material. So in this case, I have a wooden ball. I can do it with a ping pong ball. The same thing will still happen. Okay, there's no interaction. Okay, it just moves past. Okay, no interaction. Okay, sure. Okay, so from the video, as you can see, right, the metal ball actually moved in a straight path, or rather in the video I actually use a wooden ball. It's to really tell you that the ball is actually a non-magnetic material. Okay, so metal, but a non-magnetic material, so you can think of it as a copper ball or a gold ball. Okay, that move past this strong magnet, so cannot be attracted or repelled, or has no interaction. Okay, not being attracted nor repelled is trying to say that it's having no interaction with the strong or by the strong magnet. So in this case, this will be the most probable answer. Okay, so let's move on to B. Okay, so for B, hero an iron ball. They give you a very specific material, iron, and iron, you know, that is a magnetic material. So can this iron ball be a magnet? Okay, in this case, most likely not. Okay, if it's really a magnet, then it should say a magnet ball. Okay, so in this case, we will take it that it is just a magnetic material. It has no magnetism, or it has not been magnetized for that fact. So you can see that the iron ball was pushed along over here, and there's still a strong magnet. Then they ask you whether is it Q, R, S, or T. Okay, so I'll show you a video of how I do this experiment in the real life setting and see which is the most logical path. Okay, so now I have an iron ball. So this is the iron ball. So let me show it to you. Or at least I prove that this is a magnetic material, but it is being attracted. Okay, it is being attracted. Okay, it's being attracted, as you can see from here. Okay, so this is an iron ball. So an iron ball itself, right, is it's a magnetic material. If I put two iron over here, right? Okay, if I put two iron, there's no interaction with them. They will neither attract nor repel. But if I put it near here, near a magnet, it will be attracted, and it will be attracted to it. Okay, so let me show it to you on this portion. So when the iron ball moves past this, okay, you can see that it's being attracted, right? Okay, so it will tend to move in this path. Okay, so let me show you from top view. It will tend to move in this path. Okay, for this path. Okay, so why is this path not possible? Because this path always show you that there's repulsion. Okay, so if this path, this path is also not possible. This path show you that it is most likely a non-magnetic material, which is on part A. Okay, and then this path is also not possible because it shows you that this repulsion, it is getting repelled by this strong magnet, so it is not possible for this direction. Though the most probable path is go through here straight over here. Okay, let me show you as best as I could to show you this. Okay, so it get directly attracted, then it stop here. So this is also another possible path. So between the four options, right? Okay, the best possible answer is this. Okay, the best possible answer. Okay, let me try to show it to you. Okay, as you can see, it took more or less this path, right? So in this case, that's why this should be the answer, okay, as referred to in the question. So as you can see from the video, right, which path of the iron ball is most likely to be the case? Okay, in most of the cases, whenever I tried it, right, it actually took off the path of R, okay, and that's because it get attracted, okay, towards the strong magnet and then change the direction of travel. Okay, so this is actually the changing the direction of travel is actually a effect of forces. Okay, so one of the effect of forces that is demonstrated here is changing the direction of a moving object. Okay, so why it cannot be Q? Okay, as I say, this one, if it's Q, right, it will show repulsion. Okay, it will be showing repulsion. Okay, in this case, it's not possible. Okay, because over here you know that Q, or rather the iron ball is a magnetic material, it will not repel a strong magnet. In fact, it will just be attracted, it will not be repelled. Okay, so T is also showing a repulsion, so it's moving away. Okay, moving away. Okay, it get pushed, okay, by the strong magnet, or as if it's being pushed. So in this case, this is also showing repulsion. Okay, so it is also not possible. So Q and T is not possible. R is basically your non-magnetic material. Okay, which in this case I show you is a wooden ball or the ping pong ball. So in this case, if it's a magnetic material, it should most likely take on the path of R. Okay, so another possible way is that the iron ball, okay, could have rolled past here and then got attracted, directly stay on here, because maybe the magnet is just too strong. Okay, it attracted directly and it stay here and stop the motion of the iron ball, as shown in the my experiment earlier. Okay, so how to really answer this question? Also, you make a choice first. Okay, you talk about it being a path R, then the evidence is really the iron is a magnetic material. So being a magnetic material, it can do what? It can be attracted, pulled towards a strong magnet, causing the ball to change its direction of motion or direction of travel. So the effect of force must be stated, and this is probably what most students forget about it. They probably will write something like attract and pull towards a strong magnet, but they will forget to write about change the direction of travel or change the direction of motion. Okay, this is part of the effect of forces. So with that, we are more or less done with this question. Thank you very much.